Hello, Dave Kenworthy here. It's the 12th of the 2nd, 2022. Today we're looking at Berriman's suggested ancient geodetic system. And it's going to produce the Giza base length that we've seen in the past three videos of 36666.666 recurring imperial inches. We're going to produce the English mile. And all we need to do all this is to use digits. And I've also used Shusey in the model because 10 Shusey equals 9 digits in Berriman's system. And all the units in this model, they're all fixed. So there are always this number of digits and Shusey in the great circle circumference. And the geodetic mile is always 100,000 digits. The English mile is 86400 digits, and that's 96,000 Shusey. You can see the geodetic mile is 1111111.111 recurring digits. Sorry, Shusey. So we can go down the two columns, and the Giza base is 50,000 digits, which is 55555 recurring of Shusey. And we can see here we've got two incredibly important units lying right next to each other in Berriman's table. And because we know there are 50,000 digits in the Giza base, we can work out how many meters are in the Giza base, how many yards, how many megalithic yards, how many geodetic cubits, how many royal cubits, how many Sumerian cubits, how many Berriman, how many imperial feet, and how many ancient feet. Because we can scale everything against the meter. We've got a stade, which is 10,000 digits, so there are 10 stades in a geodetic mile. And this is all what Berriman tells us in his book. And he tells us the meter's 54 digits. And we know when the Indus Valley yard is 3.3 foot, the English yard is 3 foot. So we get the relationship here. If we divide the meter, which is 3.3 feet, the ancient meter, if we divide that by 1.1, we get the yard. So all we need to do is divide 54 by 1.1 and we get 490909 and 5454 recurring Shusey. There's some interesting numbers on the Shusey. There's 60 in a meter and 50 in a megalithic yard. There are 54 digits in a meter and 45 in a megalithic yard. We can see that the megalithic yard times 1.2 is the meter. And this is so important in improving that Professor Alexander Thom got his megalithic yard exactly correct, and that is one of the keys of this presentation. We're going to show that at the end of this presentation. So we've got all these cubits that we can derive from Berriman's work. The royal cubit is 54 divided by 1.92. The geodetic cubit, obviously different, 54 divided by 1.9008. And the Sumerian cubit is the meter divided by 2. So all these are what you have to do to the meter to get this unit here. So 1.9008 divided into 54, you'll get that. So we can see how nicely balanced these units are. Even though they've got these 000909, we know why this is being produced. It's because they're using 0.99 as a step. So we've come down to the ancient foot, and the reason why I've done that is because of Harry Sivertson, because he's producing this, and we want to know if this system produces the same foot that Harry's telling us, because Harry's metrology is rock solid, and we have to know that the metrology produced by John Neal and John Michel and Harry will fit into this model. So that's why I've put the ancient foot there. And the other thing we need to notice here is we've got 31.565656 geodetic cubits are producing that number of Shusy, and royal cubits are producing that number of Shusy, and we know 3.125 is Babylonian pi, and we know that that unit there, if we divide it by 10, will be 2,500 divided by 7920. And that's top of the range pi used within the Giza design, apart from Egyptian pi. And I've produced a video about these two units working together. But I'm not going to talk about that now, because we're just going to have a look at what's happening here. Because like I say, the only thing we need to do in this model is put the digit in it. We put the digit in that cell there, and there's a whole table of calculations that will be produced here. So let's have a look at what happens. It says the table above can be completed by entering the digit value as indicated. The references in Berriman's book, Historical Metrology, are, and I've put the page references of all the units there, where I've picked up and worked out these numbers in digits for the units that are in the above spreadsheet. So let's go down to the next page. What can we expect from this model? The key findings that can be tested using Berriman's Shusy times 10/9, the digit, are: 1. The English mile. Does the system give the correct measures in inches, feet and miles? 2. The Giza base length. Does the system continue with the suggested designer's intention of 36666.666 recurring imperial inches? The Megalithic Yard. Can this be proved to work at Giza? Will there be 1111.111 in the Giza base? The Royal Egyptian cubit. Will the system give Berriman's value of 20.625 imperial inches? The meter. Will this be two Sumerian cubits of 19.8 inches, which equals 39.6 inches? Will the imperial foot be 12 inches? And will the ancient foot align with Sivertson's value of 11.7333 imperial inches? Will the Riemann be equal to the eclipse unit of 14.666 imperial inches? Will the units below the meter all agree to the metric proportions as indicated? Will the Giza base be confirmed as 1 divided by 43200 of the great circle circumference? And then we put the digit in. We work it out. Test results using page 3, the Shusy as 0.66 inches times 10/9 equals 22/30, which equals 0.733 ... recurring for the digit. So we put that number in, enter the digit below, and we can look at what we're getting. The great circle circumference, these are unchanged. They will always be the same no matter what number goes in there for the digit. So we look at the number of inches, feet and miles in the great circle, and it's 25,000. And the geodetic mile is coming out at 6111.111 imperial feet. And the English mile, 86400 digits, we're looking at time, obviously. The English mile can represent 1 day in time. That's 63360 inches, 5280 feet, and 1 mile when we enter the digit below. The stade is just 1/10 of the geodetic mile, and now we come to the meter. 54 digits, 60 Shusy, 39.6 inches, 3.3 feet. The yard, 36 inches. The megalithic yard, 33 inches. The geodetic cubit, 20.8333 inches, 20.625 for the royal cubit, 19.8 for the Sumerian, 14.666 recurring for the Riemann, 12 inches for the imperial foot, and 11.7333 inches for the ancient foot. So we can tab down and see what's going on. Conclusions. The key findings that can be tested using Berriman Giza times 10/9 the digit are: 1. The English mile. Does the system give the correct measures? Yes. They're confirmed. Giza base length. Does it continue with the suggested design and intention of 36666.666? Yes. Megalithic Yard. Will there be 111.111 in the Giza base? Yes, the variable Megalithic Yard's 33 inches. So then again, 36666.666. The Royal Egyptian cubit confirmed as 20.625. The meter, 2 Sumerian cubits, 39.6, confirmed. Imperial foot, 12 inches, confirmed. Ancient foot, 11.733, confirmed. Eclipse unit, 14.666, confirmed. Will the units below the meter all agree to the metric proportions as indicated? Confirmed. Will the Giza base be confirmed as 1/43200 of the Great Circle circumference? Confirmed. Berriman's system's open to challenge, but it's unlikely, given the above findings, that it is anything other than the one used by the ancient astronomers, geometers, and designers of the Giza Great Pyramid. So finally, the system can be confirmed as astronomical, using 366.666 days as the solar year and 352 days as the lunar year, facilitating the prediction of eclipses. It's geodetic, obviously, from what we've seen, using a scale based on a circumference of 25,000 miles that produces accurate equatorial and polar circumferences, using the cubit as a geodetic unit. When the linear unit is discovered at the Stonehenge Greater Cursus, when it's 1320 feet, being a quarter of a mile, the Great Circle is 100,000 units, and Professor Thom suggested this was considered by the ancient designers as universally sacred. We got 10 fingers on our 2 hands, so we know where that's coming from. Geometric. The use of root 2 and root 3 as variable units is confirmed in Berriman's analysis. Time-based. We've already seen the simple Giza time theory, and it's that 100 inches represent 1 solar day. The inch represents 864 seconds within the design, giving a base length, as we all know. And again, the design is based on the product of linear land area and pi cubed units, giving a base length of 366.666, as we know. The central unit in the design, excuse me. Now this is something very important because this is about Professor Alexander Thom. And the central unit in the design of the Giza Great Pyramid is the Megalithic Yard. And I've made a mistake in there. Should have another 1 in it. The central unit is the design. In the design is the variable Megalithic Yard of 1111.111 recurring units. In the base, I must have been falling asleep when I did this. In the base being 10/9 times 1,000 units of 33 inches. When Thom's value for the Megalithic Yard is used in the design, 32.64 inches, the base length loses exactly 1 day off each side, 400 inches in total, being 36266.666 inches. We'll look at that now. Professor Alexander Thom got it right. I mean, I've been working on this for 8 years, and there's absolutely no doubt that Professor Thom got things absolutely right with his Megalithic Yard, and we can show that now. So here we are. This is the spreadsheet that we're working on. Enter the digit below. Well, we know the digit is 22 divided by 30. So, plus 22 divided by 30. And there it is, 0.733 recurring. And look what it's producing, all those figures that we've gone through. So we know that there's Harry's ancient foot at the bottom there. All those units that we've talked about are all there, just produced by entering that one digit. And what we can now do is, because we've got the megalithic yard in the calculation, we know there are 45 digits in the megalithic yard. So all we've got to do to put the digit in there is put plus 32.64 divided by 45, and that gives the digit associated with Thom's megalithic yard. And there's Thom's megalithic yard, 32.64. And look at all these units that are being produced. They all look very nicely balanced. We've got 130560000 feet in the great circle circumference, and that's 24727.2727 recurring miles. And what happens when we see how that's been scaled against the great circle of 25,000 miles? So we go plus 25, 123 minus that. It's giving 272.72727 miles. And how much is that in feet? What can I say? Thom got it absolutely right. When we put Thom's measure into this model, we get a distance of exactly 144,000 imperial feet in the Earth's circumference from the standardized 25,000 miles circle. It's deliberate. So when you use 32.64, it produces this. Now, there is the Giza base, 50,000 digits, 36266.66. It's exactly 400 inches different than when we put in, just watch that cell change. It's gone to 366.666, not 362. It's exactly 400 inches, 100 inches each side. They've taken 1 day off each side, when 100 inches represents a day. So let's just go back. And there it is, 3626666. So this model is working perfectly, and it's proving that Alexander Thom was absolutely correct with the length of his megalithic yard, which is 32.64. And what we find is the meter that comes from this model is 3.264 feet. So you divide that by 10 and change it to feet to get the meter, the megalithic yard, because it's 1.2 different. Multiply that by 1.2, you get that. 39.168 is the meter that needs to be used within the design of the Stonehenge Aubrey circle, and the other two circles as well that Thom identified at Stonehenge and measured. And when we do that, we find again that amount there in the inner Sarsen circle is 100 meters. So Thom's measures at Stonehenge and at Giza work perfectly. So that's all I want to say. Thank you.